All right, everybody, we are on lesson number 6, a very, very short lesson. Only 3 things you need to remember from this lesson, which are the trig graphs, however, very important moving forward. So, a couple of things. We're going to look at what are called periodic functions, and those are functions that look like waves. Well, they don't have to look like waves, but they repeat themselves, okay? Now, how often they repeat is called the period, okay? And we're going to look at that in a sec, but basically you measure it as the distance between peaks, peak to peak, or trough to trough, or midpoint to midpoint. We're going to look at that on the graph here in a sec. The amplitude is half the distance between the maximum and the minimum values of the function, i.e. it's the max value of the function minus the min value of the function divided by 2, and that is amplitude. Okay, so look at these 3 graphs here. We're going to find period and amplitude. Period. How often does it repeat? Well, you can go peak to peak. So what's the distance between the 2 peaks? 10 to 2, or 2 to 10. So it's 10 minus 2, which is 8. So that has a period of 8. I don't know what those units are, but that doesn't matter. Or you could go this point here, because the graph is starting to rise, and you go to the next rising part. This graph is falling here, so not that, to here. Graph is rising. What's the distance between those two? The 8 minus 0, which is 8. Same answer, so that's good. And finally, you could do the difference between the troughs or the bottoms. What is this distance? Well, it's 14 minus 6, which is, you guessed it, 8. So the fact that we got all the same answer is good. So that's the period. Now, if we're going to do amplitude, that's easier. Amplitude, max minus min, divided by 2. So what's the max value of the function? 10. Doesn't matter which one you use, they're both maxes of 10. What's the minimum? Negative 10. So it's minus negative 10 divided by 2. 10 minus negative 10 is 20 over 2. So the amplitude is 10. There you go. All right, next one. Find the period. Peak to peak. 9 minus 3, 6. We're just looking for that distance. Or you could do trough, trough, minus 0. Or you could do this one, that's 9. You're going up by, what are they going up by? 1, 2, going up by 1 is 9, 10, 11, 12 there. 12 minus 6, 6. So period is 6. Okay. Amplitude. Is the max value minus the min value divided by 2. What's the maximum? It is 6. What's the minimum? Negative 2 divided by 2. That's 8 over 2. So the max value of, or an amplitude of 4. And the final one. So we could go from this part. It just starts to fall. So you go to the next falling one. That's coming up. The graph is coming up. So we do this one here. That's 10 minus 0. The period would be 10 minus 0, which is 10. Or you could just go, whoops. Okay. Do we not want to erase? We don't want to erase. We use a different color. Could go from the bottom here, where it's falling, to the next falling, which is there. 10 minus 0 is 10. So period is 10. Now, the amplitude is max minus min divided by 2. maximum value is 6, minimum value is 2. 6 minus 2 is 4, 4 over 2 is 2. So the amplitude is 2. Okay. Now, the trig graphs. So the first one we're going to do here is we're going to look at the sine graph. We're going to do it in blue. So this is going to be the graph of y is equal to sine x. Okay, so on your calculator, these are all in degrees. If you go sine of 0, sine of 0, you should get 0. Now, sine of 30, you get 0.5. Sine of 60, we're not doing. Sine of 90, you should get 1. Not doing 120. If you do sine of 150, you should get 0.5. And if you do sine of 180, you should get 0. Continuing on, sine of 210 degrees on your calculator should give you negative 0.5. Don't worry about that one. Sine of 270 should give you negative 1. Don't worry about 300. Sine of 330 should give you negative 0.5. And sine of 360 should give you 0. So if we plot those, 0 degrees, this is x-axis is all in degrees, y-axis has no units, so 0, so add 0, x is 0, y is 0, right in the origin. When x is 30, these are going up by 30s, 30, 60, 90, x is 30, it's 0.5, so that is 2, 4, 6, 8, 1, so 2, 4, 4 right there. Sine of 90 right here gives me 1. Sine of 150, so we're going up by 30, so that one's right there, gives me 0.5 again. Sine of 180 gives me 0. Sine of 210, so that's this point right here, gives me negative 0.5, 2, 4 there. 270 gives me negative 1. 330 gives me negative 0.5. And 360 gives me 0. So if you connect those points, that is your sine graph. That is the basic sine graph between 0 and 360 degrees. Now, you remember, this is 0, 90, 180, 270, 360. But we can keep going. Once you go around once, that's what we've done and plotted it, you can keep going. So this would be 360 plus 90. It's 360 plus 90 is going to be 450. And at 450, if you put that into your calculator, sine of 450 degrees, you should get 1. You can keep going. 360 plus 180 is 540. If you do sine of 540, you'll get 0. So the graph actually keeps going. In fact, it goes on forever in the positive direction and in the negative direction, because we could start at this point and go here. And that would be negative 90 degrees. And if you do sine of negative 90, you're going to get negative 1. So the graph in the negative direction. 180 will give you negative 180 will give you 0. 70, negative 270 gives 1. And negative 360 will give you 0. So that is actually the sine graph in both directions, from negative 360 to 540, but it can go on forever and ever. Okay, a couple of things I want you to remember about this. The domain of the sine graph is all real numbers. Unless you set the domain, it is the set of real numbers. It can be anything. The amplitude, all right, Amplitude is max minus min. What's the max? It is 1. What's the min? Negative 1 over 2, which is 2 over 2, which is just 1. Sine graph has an amplitude of 1. What is the range? Well, i.e., what does the y values go between? The y values of a sine function are always less than or equal to positive 1, but greater than or equal to negative 1. They just oscillate between 1 and negative 1. Okay. The period of this graph, how often does it repeat? Look at the center. When you come back to the rising part, boom, 360 degrees. So it has a period of 360 degrees. X-intercepts, where do they occur? 0, 180, 360. 0, 180, 360 degrees. All right. And you could say negative 180, negative 360. I mean, you could write them all out if you want. We're not going to. The y-intercept, there's only one. It is 0, the origin right there. Okay, that's the sine function. You need to know that. You need to know how to sketch it. I'm going to summarize this at the end, exactly what you need to know. All right, let's move on to the cosine function. Notice this one they did in rads. That'll make everybody happy. Again, we're not going to do all of them, so we're going to do cosine of 0. Calculator. Remember, these are in rads. At cos of 0, you're going to get 0. We're not going to do pi over 6. Pi over 3, which is anybody? 60 degrees. If you do cos of 60, you'll get 0.5. Pi over 2, which is 90 degrees. If you do cos of 90, you will get 0. 2 pi over 3, which is 120. You'll get negative 0.5. We're not doing that one. Cosine of pi will spit out negative 1. And that 4 pi over 3, that's 4 60-degree angles. 6 times 4 is 40. That has a value of negative 5. 3 pi over 2. Hopefully somebody gets pi over 2 is 90. It gets 3 90-degree angles. 270. Cos 270 is actually 0. 5 60-degree angles is 300. So it's cos of 300 degrees. And that will give you a 0. Not doing that one. 2 pi is 360. I hope you remember that. And then I'll give you 1. So this graph has 0. I say cos of 0 is 0? Wow. Hopefully somebody was doing this and saw that, because it's not. It is 1. Can't believe that is a very bad mistake. Cos of 0 is 1, so we start there. Pi over 3, which is 1, 2, 3, right there. Sorry, that's pi over 2. Pi over 2. Pi over 3 is right there. That's value of 0.5 right there. Pi over 2, 2 pi over 3, we're going to go to negative 0.5, or we're just going to plot the nice easy ones. Pi gives me negative 1. 3 pi over 2 gives me 70, so 3 pi over 2 is right there. Gives me 0, and 2 pi gives me 1. So the graph of a cosine starts at 1, down. I'm just skipping that one. Let's erase it. Why is my eraser not working? Okay, whatever. Comes through here, turns, comes there. Okay, looks like a V, but in reality, as you know, it actually repeats, just like the sine graph. Sorry about that. There's the cosine graph. That's y is equal to cosine of x. Okay, a couple things about this. So the difference between that and the sine graph is it starts at 1. Okay, so let's summarize this. We'll just write them on the side here. So the domain, does it have a domain restriction? No. That's all real numbers, unless you place a domain restriction on it. The range, just like the sine graph, y values oscillate between -1 and 1. The amplitude, max minus min, 1 minus -1, divided by 2 is 1. The amplitude is 1. The period, how often does it repeat? Well, from here to here is 2 pi or 360. Could be 2 pi. The x-intercepts of the cosine graph, that's pi over 2, that's 3 pi over 2. In other words, where they are 0. And that one, I don't know why I wrote that is, that should be 1/2, sorry. The x-intercepts are, I'm just going to do them in degrees, 90 and 270. I will summarize this at the end of this lesson. And the y-intercept is 1. Okay, that is the cosine graph. All right, there was only one left, peoples, and it's the tan. It's a bit weird. So, tan graph. Tan of 0 on your calculator, you are going to get 0. Okay, let's do tan of 45, do it on your calculator. You will get 1. Don't worry about those ones. Tan of 90, your calculator will say error, and it's because it is undefined at 90. Now again, forget about all these. Tan of 180, you're going to get 0. Okay, so I'm just going to show you the tan graph. The reason it's undefined at 90 is in lesson 5, but lesson 5 is optional. So if you want to know that, you can go back and look. Otherwise, you just have to take my word for it. So these undefined means at 90 degrees. So right there, tan has asymptotes. Okay, because you cannot divide by 0 is essentially what you're getting. So at 90 degrees, you have an asymptote. Now, if you did tan of 270 degrees on your calculator, that is undefined as well, which means at 270, that is 90, this is 270, you have an asymptote as well. And if you went to negative 90, you have an asymptote, and negative 270. So the tan graph is a bit different. It looks like this. 0 at 0, and then it starts to climb, but it can never hit the asymptote. On the other side, it comes down, it never hits the asymptote. and then it repeats that pattern in all these little sections with, remember, tan 180 is 0, so there's an x-intercept. So it comes up, passes through that point, and just skims, but never touches the asymptote. Same with this, comes up 360, and there would be another one, but it would run out of room here. Negative 180. And then going at 360, it would just climb like that. Right, tan graph. Now, obviously weird. Most of the graphs we deal with are sine and cosine because those have applications in real world, or simple applications, I should say. Tan is a little more complex, obviously. So let's look at the domain range and all that kind of stuff. So the domain, so tan of x, the domain. Well, x cannot equal what? Cannot equal 90, 270. I'm just going to do between 0 and 360. So it can equal 90 and 270. The range of this graph, now the range of the other two graphs was +1, -1. This one, these climb forever, so there is no range. Okay, it's all real numbers. Right? It just keeps going forever up. The period, and this is also where it's different from the sine and cosine. How often does it repeat itself? Well, what's the distance between these 2 points? 180. It repeats itself every 180 degrees. Okay. The x-intercepts are 0, 180, 360. And y-intercept is 0. And the vertical asymptotes and the VAs are same as the domain restrictions. 90 and 270 degrees is where they occur. All right, so what do I expect you to remember from these 3 graphs? Well, here's our notes page, the summary. Okay, this is all you need to remember. One, you need to know how to sketch these graphs. So if I say sketch the sine graph, you need to commit to memory, so write it out a bunch of times. If I say sketch the sine graph, you need to be able to go, okay, I know it starts with 0, looks like that. That's 0, that's 180, that's 360, so that means that's 90, and that's 270, that's 1, that's -1. You need to be able to do that, okay? Because if you can do that, it means you know, right? You know all this stuff about the sine graph, okay? Sorry, cosine graph. You gotta be able to do the same thing. Cosine starts at 1, like that. That is 360. That's 0. This is halfway, so that's 180. That's 270. And that is 90. That's 1, and that's -1. You need to be able to do that. And then finally, the tan one. You need to be able to go, well, there's asymptotes at 90 and 270. Starts at 0, like that. Comes up. This x-intercept 180, and then it goes to 360. That's what you need to be able to do for all 3 graphs, okay? There's no questions for this. You just need to commit those to memory because the next section or the next lessons are basically doing transformations on these. I know everybody hates transformations, but it's transformations of trig functions. Please commit those to memory. All right. Good luck, people. Thank you.